Welcome back to the sixth and final chapter in Algebra on Statistics Part 2. In this section, we're going to learn how to draw a histogram. But before I teach you how to draw a histogram, I want you to know when to draw a histogram. So if you remember our discussion on pie diagrams, the example I gave you, it had various items on which you spent your pocket money in the last month, if you remember. And in that example, the order of the items was not important. So for example, instead of food, if I had books as the first item or movies as the first item, it would not make any difference to our pie diagram. Because even in the pie diagram, there's no order to the items, right? In a circle, it doesn't really matter where you start. You can start anywhere and start counting the items from that point. On the other hand, you might be given a data set where the order of the items is actually important. Okay, so the order in which the items are arranged is an inherent part of the data set. In that case, you would use a histogram to represent that data set instead of a pie diagram. So I repeat, if the order of the items in your data set is important, then you would choose to draw a histogram instead of a pie diagram. So let's go ahead and take a look at one such data set. Here we are going to look at the marks obtained by students in a class in some examination. Okay, so in the first column of our table, we are going to write down the class intervals for the marks. From the previous chapter in Statistics Part 1, you should be familiar with class intervals. And if you remember what I said there, when you see class intervals, you know that the data is grouped data. So let's go ahead and write down the class intervals of the marks. So the first interval is 0 to 20 marks. Then we have 20 to 40 marks, 40 to 60 marks, 60 to 80, and finally 80 to 100 marks. And in the second column, we write the frequencies, which is the number of students in each class. Meaning, in the first row, we will write how many students got between 0 and 20 marks. So in this case, we find that 5 students got between 0 and 20 marks. So we go on writing the frequencies of each class in the second column. So for 20 to 40 marks, our frequency or number of students who got those marks will be 15. The third row, the frequency is 20. The fourth row or the fourth class, the frequency is 10. And finally, our last class, 80 to 100, the frequency is 7. So 7 students got between 80 and 100 marks. So given this data, now you can see that these marks, these classes are in some kind of order. This class, the first class, is smaller than the second class, right? Students in this class got lesser marks than students in this class. So, and so on. So we see that these classes are in some particular order. You cannot just take this class first. It would not make sense, right, to put it first. You have to go in some kind of order. Like here, we've arranged them in ascending order. So when you have a data set where this order is important, then the figure that you draw is a histogram instead of a pie diagram. When the order is not important, you draw a pie diagram. If the order is important, you should draw a histogram. So let us go ahead and see what the histogram for this data set looks like. So first we go ahead and draw our x and y axes, our coordinate system. And on the x-axis, we are going to have the marks of the students. On the y-axis, we'll have the number of the students or the frequency of the students. So x-axis, you will have your class intervals. On the y-axis, you have your frequency. So how do you draw a histogram? If you remember our previous chapter, the last chapter 5 on Statistics Part 1, you're already familiar with histograms because I'd used histograms to derive the formulae for the mean and the median and the mode. A histogram looks something like this. And if you remember our discussions in chapter 5, then you know that each class is represented by one rectangle, right? So this one represents the first class, this rectangle represents our second class, this one the third class, and so on. So the width of each rectangle is equal to the width of the corresponding class, and the height of the rectangle is equal to the frequency of the class. So if you look at the first class, we can tell that the class intervals were 0 and 20, right? The lower limit was 0, the upper limit was 20, and the frequency of that class or the number of students in that class was equal to 5. So you just draw this horizontal line at the level of 5, and for the entire rectangle you take the vertical lines, one at 0 and one at 20 on the x-axis. So doing this you can draw all these rectangles and get your histogram. Drawing the histogram itself is a very simple procedure. You just draw your x and y axis, you label each of them, and you draw your rectangles and you have your histogram. There are two other elements which you should not forget when you're drawing histograms in your examination. One of them is the scale of the histogram. So the format for the scale is you need to mention on your x-axis what is 1 centimeter on the x-axis corresponding to, and similarly you mention what 1 centimeter on the y-axis corresponds to. So in this case we say on the x-axis 1 centimeter corresponds to 10 marks. So 1 centimeter equals 10 marks, and on the y-axis if you see 1 centimeter is equal to 5 students. So we go ahead and write on the y-axis 1 centimeter is equal to 5 students. So this is one element that you need to mention, the scale. The second element is the title of the diagram. So in this case it is the histogram of marks obtained by students, and this title will go at the very top of your diagram. So at the top you write the title. Usually somewhere on the right of your histogram you will write the scale. I'm going to give you a mnemonic which will help you to remember all the elements that you need to mention when you're drawing histograms in your examination. You can't simply draw these rectangles and sit back and relax and think you'll get full marks. You need to draw all these other elements as well in your diagram. If you do not include them, you will lose marks in your examination. Whenever you're dealing with histograms or frequency polygons or frequency curves, we'll see all these are pretty much the same. You need to remember, don't forget to add salt. What does SALT stand for? Scale, axes, labels, and title. So whenever you draw a histogram or a frequency polygon or a frequency curve, always apart from the rectangle and the lines, write down your scale, write down your axes, x and y, label your axes with what you're measuring on each axis, and write the title of your diagram. So always remember to add salt when you're drawing histograms or frequency polygons or frequency curves.